Hello everyone, my name is Cédric Derue. I'm a lead software product engineer working at Capgemini and also HashiCorp ambassador. So thank you for joining me today to explore how we can transform infrastructure management through no-code solutions. In my years working with engineering teams, I have constantly seen one challenge. As our systems grow more complex, the expertise required to manage them effectively becomes increasingly specialized. Think about your whole organization for a moment. How much time does your team spend on routine infrastructure tasks? How often have innovative projects been delayed because of infrastructure bottlenecks? These are the challenges we will address today. So, if you are focusing on some key challenges in modern engineering, first, we will find the complexity barrier. Managing today's cloud-native infrastructures requires mastery across multiple domains, networking, security, let's say containerization, automation, cloud services, and so on. Developers often find themselves tangled in operational complexities rather than focusing on their core expertise, writing great software. This reliance on specialized knowledge leads to bottlenecks that slow down the entire organization. The second challenge is probably the scalability challenge. As an organization grows, its infrastructure demands evolve rapidly. However, the expertise required to manage them doesn't scale at the same rate. More teams, more applications, and more cloud environments mean a never-increasing burden on DevOps and operation teams, creating inefficiencies and delays. And the last challenges is the consistency problem. Different teams often tackle infrastructure challenges in their own way. This lack of standardization leads to configuration drift, maintenance nightmares, and worst of all, security vulnerabilities. Without an unified platform approach, businesses risk losing efficiency and increasing operational overhead. Now, let's talk about platform engineering. Imagine a world where every developer in your company is free to focus on innovation, building incredible applications without being bogged down by complex infrastructure issues. What if there was a way to remove bottlenecks, streamline workflows, and make scalability a seamless experience? That's exactly what platform engineering brings to the table. So consider this definition. Platform engineering is the strategic discipline of designing, building, and maintaining toolchains and workflow that empowers software engineering teams with self-service capabilities. Consider that it is like constructing a well-oiled highway system, a solid foundation that allows developers to navigate effortlessly, accelerating software delivery while ensuring reliability and security. So, finally, what platform engineering is the answer? In fact, we have to consider that platform engineering is not just about automation. It's about enabling developers to do their best work without to worries about the underlying infrastructure. Here's how it is solved the challenge: by abstracting complexity, by creating an internal developer platform, or EDP, with pre-configured tools, best practices, and automated workflows Platform engineering shields developers from operational overhead. Think of it as providing an intuitive control panel such as developers get what they need without digging through layers of complexity. After that, it enables scalability. A well-architectured platform grows with your organization. It standardizes processes, enforces best practices, and ensures that no matter how many teams or applications you have, the underlying infrastructure remains efficient, reliable, and easy to manage. And the last point is that platform engineering ensures consistency and security. With a platform engineering approach, security and compliance are backed, not added as an afterthought. Standardized applications, policy enforcement, and automated security checks ensure that every deployment meets organizational standards, reducing risk and increasing, of course, peace of mind. So, what is the promise of no-code infrastructure in this discussion? Traditional infrastructure management requires extensive knowledge of configuration files, scripting language, and cloud architecture. This is not only slow down operations, but also create bottlenecks when organizations need to scale. That's why no-code infrastructure solution bridge the gap by enabling users from developer to IT professional to manage infrastructure efficiently without the need for deep coding expertise. The key benefits of no-code infrastructure tools are, for example, to provide visual interfaces or say goodbye to writing complex script. No-code platform offers an intuitive, for example, drag and drop environment where user can design and configure infrastructure components in a matter of minutes. This reduces the risk of misconfigurations, enhance productivity. It provides also pre-built templates and components, speed up deployment by leveraging pre-configured templates that incorporates, of course, industry best practices. Whether you need a database setup, a containerized application, or a security compliant architecture, no-code solution tools provide reusable components that streamline the process. Okay. We have also automated validation and security check. So ensuring security and compliance is crucial, of course, in any infrastructure setup. No-code solutions comes with building security policies, automatic compliance checks, and real-time monitoring. This means fewer vulnerabilities and reduce manual oversight, ultimately strengthening an organization's security posture. You have also standardized workflow and governance, eliminating inconsistency across teams by enforcing standardized workflow. No-code platform provides centralized policy management, ensuring that every infrastructure deployment adheres to predefined governance principle and operational standard. This leads, let's say, to more control, predictable, and scalable infrastructure strategy. It is also about best practice by default. No-code platform incorporate industry best practice, so teams don't have to build their infrastructure strategy from scratch. From automated scaling to optimize resources allocation, these tools ensure efficiently while reducing operational costs and, of course, human errors. And the last benefit is, of course, faster innovation in collaboration. By simplifying infrastructure management, no-code platform free up engineers to focus on strategic initiatives rather than repetitive configuration tasks. this fosters a culture of innovation and enable teams to collaborate more effectively across disciplines. Now, how HashiCorp Cloud Platform can empower platform engineering. So we look just after that at the HashiCorp Cloud Platform with Waypoint and Terraform to see how it can transform application deployments and infrastructure management. So Waypoint provide a consistent way to build, deploy, and manage application, and of course the underlying infrastructure. HashiCorp Waypoint is I would say a no-code internal developer platform that enable platform engineering teams to define golden patterns and workflow, providing developers with a seamless self-service experience. By integrating HashiCorp Terraform with its no-code infrastructure capabilities and HashiCorp Waypoint, it allows platform engineers to standardize application deployment and infrastructure provisioning without require custom and complex scripting. So with this approach, platform engineer can enforce best practices while reducing complexity for application developers. Whether responsibilities are distinct or shared, HashiCorp Waypoint simplify both infrastructure and application operation from day 0 to day 2, ensuring consistency, scalability, and operational efficiency across the organization. So, for example, imagine you are deploying a microservices application. Basically, traditionally, you will need to manage multiple deployment configuration, handle container organization stack, and set up monitoring for each services. With Waypoint, this becomes a guide, streamlined process that any members can handle safely. Now I propose a short demonstration. So I will switch to the browser, just like that. So we'll start by speaking at the basis of no-code infrastructure module. So you can see my GitHub account with a repository that contains a Terraform module that is ready for no-code infrastructure module. No-code ready is an important concept here because the particularity, the specificity of a no-code module here is that, for example, the provider configuration is included within the root module itself, while basically standard Terraform module avoid to include the provider configuration. So it is the main difference between a no-code ready Terraform module and a standard module. So here it is just a module that is developed to provide provisioning an Azure container apps environment with Terraform. So for those that know the Azure RM provider, for example, we can recognize the main resources in Azure that are needed to provision an Azure container apps. Okay. So now the goal is to provision, it is to create, to publish the no-code Terraform module into the HashiCorp Terraform registry. So it is what we can see here. So we have our Terraform module, and we can recognize the basic information we can see here. So, for example, the number of and the type of Azure resources it will provision. So we can recognize the Azure Container Apps, its environment, and a logalactic workspace, and of course, a resource group that encapsulate all these resources. So if you want to publish your own model, you can start, for example, from GitHub, like me, and after that, you have to go to the home page of the registry. You can click on Publish Module. You select the version control provider where your no-code Terraform module is hosted. You select your repository. And after that, you have to add module to no-code provision allow list by checking the checkbox. Okay. And you click for to publish module. It's just simple like that. Okay. That being said, now we can switch to Waypoint. So Waypoint is accessible from the HTTP portal. You can click on Waypoint here. And after that, we can create some artifact, I would say, templates, add-ons, and applications. So the first step is imagine I am a platform engineer, and I will create a template to describe my application and the underlying infrastructure. So I just name my template. A summary is also required, but I will make the thing simple. And that's the moment to select your no-code module for infrastructure. Okay, so for example, I can select one of those. If I select the Azure Container Apps module, I select it. I can target, of course, an HTTP Terraform project for this template, and here I can configure the input variable for this template. So you have two options here. The first option is you set the value in the template, or you keep this value empty to enable this value to be defined when the application is created from the template. So for example, here, I can enable these two input variables, the application name and the Docker image I will get from a registry to deploy on Azure. And beside that, I can fix the environment in the template and the location to ensure to make sure that the application will be deployed on the right environment, the production environment, and for example, in the right location, West Europe. So if I fix now this variable, I cannot override this variable when I will create the application later. Okay, so we click on next and validate, and up. So it's time to describe. You can describe your template as you like, but you can also import the README from the GitHub repository. You can also mark the template with some label. I can add labels from serverless and Azure, for example, and publish the template. So it's really simple. So I am the platform engineer. I have created a template with Waypoint to standardize, to streamline the process of publish an application on Azure, on the Azure Container App Services. Now, that being said, I can create an application. So to create an application, of course, I have to choose a template. Now imagine I am a developer this time, and I select one of my templates. So here I can select HashiTools, the template I had just created. and I can give a name, and here we find the two input variable that we don't affect a value previously. It is now the correct instant to set the name of the app and to set, for example, an image, Docker image that we will get from Docker registry, and validate and create the application. Also for create item data template, I think it's already exists. Application, yes, HashiTalk already exists. Can just create with another name. Okay, no problem. So back to application, create an application, select the template. So up, this name, the name is HashiTalks, and image the same. Okay. Now create an application. Okay, now it's good. So as you can see, now we start to provision an application workspace in HTTP Terraform. So I click on the link. And as you can see, you can recognize the workspace environment, and you can see the Terraform plane that is finished. So you can see that 4 new Azure resources will be created. The apply is cleaning, is running, it's okay. So it can take a few minutes to provision all the Azure resources. So already exist. Maybe it's not good. Yes, the resource group already exists. It's not, normally it was deleted previously. So it's not a problem. It can take, yeah, it's okay. So now we are provisioning the right resources. So we will not see the result because it can take many minutes. So at the end of the run, we can see this result. We have created a resource group, another resource group with this name, and inside the Azure resource group, we have the Azure Container Apps environment, the Azure Container Application, and a log analytic workspace to supervise the application. Here you can find a real-world example of we are discussing. So it is the design of a complete platform engineering solution. You can recognize the main part of Azure DevOps with version control, CI pipeline, an Azure Container Registry to publish some Docker images. And here, the delivery plane, is implemented and supported by HTTP Terraform and Waypoint that provide, as we just seen together, the templates and some modular components for infrastructure here. So now I think it's time to make the conclusion. As we wrap up, I want to emphasize that the move to no-code infrastructure isn't just about technology. It's about empowering your teams to innovate faster and more safely. Here, if you are interested by this, here are your next steps. So the first step is to assess your current infrastructure bottleneck. Second one is to identify repetitive tasks that could benefit from standardization. An additional advice also is to start with small, start small with a pilot project using HTTP Waypoint and HTTP Terraform. And of course, measure the impact on team productivity and deployment speed. That's my conclusion. So I would like to say thank you to everyone, and feel free to discuss further about platform engineering and how HashiCorp can empower that. Thank you.